Welcome back to the second video of the unit, and we're going to look at hexadecimal conversions today. So we covered it a tiny bit in the last video, but I didn't really talk about hexadecimal much. So first things first, we need to look at what is hexadecimal. So hexadecimal is a base 16 number system where we can use both numbers and letters to represent large numbers in a small amount of space. It's usually used in things like HTML colors, it's used in error codes, that kind of thing, and the whole point of it is that it's a lot shorter, which makes it a lot easier to convert. So what numbers do we use? We've said we've got 0 to 9, they stay the same, and then A is 10, B 11, C 12, and so on, all the way up to F, which is 15. Okay, we saw this on the previous video. The right hand column represents a 1, then next one's times by 16, and 16 and 16, so it goes 1, 16, 256. Now I've never seen a number bigger than 256 in an exam, but you know, they could always surprise us. Converting binary to hex is really easy, because we've said we split into nibbles, however many nibbles there is, 12 numbers, then you've got 3 nibbles and so on, and then we split them into their own individual ones and then convert. So we can see we've got 9 there because we've got 8 plus 1, and then we've got 2 plus 8, which is 10, which means it's an A because it's bigger than 9. Now if we're converting binary to hex, there's 2 ways of doing that. The first one is the easier method, where you just convert to binary and you split into nibbles and then convert them to hexadecimal. It's the opposite of the previous slide. So for 120, we calculate a number which is 0, 1, 1, 1, 1, 0, 0, 0. Then we convert them into their own binary numbers, which is 8. Then we've got 7, because it'd be 1, 2, 4, 8 on the left hand side. So the number is 7, 8, not 78. 7, 8. To make sure it's correct, you times 8 by 1 and add that to 7 times 16, which works out because I've already checked, don't worry. The second method is you divide 120 by 16. Now the whole number is the left column and the remainder is the right column. So for this kind of number, you would have 120 divided by 16 is 7. So 7 times 16 is 112, which means we've got 8 left over. So it'd be 7, 8 again. Really simple. The reason I don't like method 2 so much is dividing by 16 can be a bit of a pain, and also doesn't really take into account when you've got 3 columns. A really big number doesn't necessarily work that well. When you're converting a binary number to hexadecimal, there's 2 ways to do it. Okay, the first way is my preferred way, which is what we do is we take the 188 using the previous video, using the same technique of dividing by 2 to create a binary number. Then we can just split that into the 2 nibbles, the left number and the right number, and we're done. Okay, that's one method. So method 1, convert to binary, then do bin to hex. The second method is slightly different. Okay, what we can do is we can do 188 divided by 16. Okay, then what we do is, instead of being like binary where we look at like remainder 1, remainder 0, we actually just do the whole division and the whole remainder. So what I mean by that is we do 188 divided by 16, which is 11. Okay, so we've got 11 there. So that is going to be our left hand number. So if we've got our 16s and our 1s column, we've got 11, which would be B. Okay, now if we do 16, or so 16 times 11 is 176. So if we do 188 take away 176, we're going to be left over 12. Okay, so 188 take away 176 equals 12, which is there, which is C. So our final answer would be B, C. So that's the other way of doing it. I personally don't like this way. The reason I don't is you're in an exam where you're not allowed a calculator. So how are you going to divide by 16 if you've got a dodgy number? I think that's a lot more difficult than just converting to binary by dividing by 2. It might take a little bit longer, but normally most people I feel have the time. Hexadecimal to binary is really simple. All we need to do is look at these numbers separately. So we've got A, which means 10. We've got B, that means 11. So all we have to do is write 10 in binary, which is going to be 8 plus 2, which is 1010, and 11, which is going to be 8 plus 2 plus 1. And then we just merge them together. So the final number would be 10101011, and that is your 8-bit number. Now for denary, we do exactly the same thing. We look at each number. So we've got the 11 and we've got the 10. Now in hexadecimal, our column numbers are, these are the 1s and this is the 16. So we do 16 times 10, which is 160, plus whatever this number is. So plus 11, which equals 171. And that is it. We've just converted hexadecimal to both binary and denary.